This video is about whether to use integration by parts, substitution, or neither. It can be hard to tell the difference between integral problems that use the two different techniques, since they look so similar. Both types usually involve looking at two functions multiplied together. An example is the indefinite integral of x times sine of x dx. As we saw in another video, this is a perfect place to use integration by parts. However, if we look at the indefinite integral of x times sine of x squared, dx, here we would use substitution. These two situations look similar but use different techniques. So what's the difference? While there are no perfect rules, here are some guidelines to use. Substitution involves composite functions, where we are looking at a function with another function inside. An example is the indefinite integral of sine of x to the fourth times 4x cubed. Here sine of x to the fourth is a composite function. In addition, there needs to be something related to the derivative of the inner function. In this indefinite integral, we see the 4x cubed as the derivative of x to the fourth. Another example is the antiderivative of negative 2 raised to the cosine of x times sine of x. The 2 raised to the cosine of x is a composite function, and the negative sine of x is related to the derivative of cosine of x. However, we might not recognize that derivative right away. The basic pattern for integration by parts is when there is a piece in the expression whose derivative is simpler than the original, and another piece whose antiderivative is not so complicated. Also, it's worth knowing that indefinite integrals aren't always solvable using the functions that we're used to. If you just pick a random indefinite integral not from a calculus textbook, the odds are that it won't be solvable. Another thing to be aware of is that there are definitely times where using an identity or trick to simplify is easier than using either integration by parts or substitution. One example is the indefinite integral of sine of x times cosine of x. It turns out that it's possible to do this using either substitution or integration by parts. However, there's also an identity that sine of x times cosine of x is equal to 1/2 times sine of 2 times x, and using this identity makes the solution pretty straightforward. Another example is 2 raised to the x times 3 raised to the x. It's possible to do this using integration by parts, but that solution is needlessly complex. Instead, this is a place where we can simplify algebraically. 2 to the x times 3 to the x is equal to 6 to the x, and the indefinite integral of 6 to the x is a basic exponential integral.